record this. Unit 3, Lesson 10, so we'll talk about finding the angle of rotational symmetry. So the angle of rotational symmetry is the angle at which a figure must be rotated to coincide with itself. And again, that just means that it's going to look the same as when it started. So to determine the angle of rotational symmetry, we need to determine the minimum angle through which the figure can be rotated, again, to look just like itself as it did when in position 0. So this number, this amount that we rotate, will always be a factor of 360 degrees. For non-regular shapes, meaning shapes that do not have the same angles, congruent angles and congruent sides, we need to determine what we call the order. And the order of the shape, again this is part of your vocab, is the number of positions in which a figure, when rotated, looks exactly the same. So we consider an order 1, or one that only a 360 rotation will map onto itself, meaning it has no rotational symmetry. So order 1 is when only 360 degrees will map it onto itself. So for example, things that have order 1 or no rotational symmetry would be the yin and yang. Again, the colors don't line up, so only 360 degrees. The dartboard, the numbers are not going to work when we rotate it, so only 360 degrees. So these are all order 1. All right, let's take a look at the examples below. And I have them over here as well. So let's take a look at the first one. So if I rotate this, oh, that looks the same. That's 1. That's 2. That's 3. Okay, so 3 positions where this shape looks the same, mean its order is 3. Let's take a look at the S. So it looks like this, doesn't look the same, doesn't look the same. That's 2. And back to the original place at 360. So this has an order 2. Let's take a look at the recycling. So 0 doesn't count. So 1, 2, back at 360 is order 3. And let's take a look at this weird shape right here. As I go around, doesn't look the same. Still not looking the same. Okay, only a rotation of 360 maps this back to itself, which means it's order 1. No rotational symmetry for this one. So order is just the number of positions in which it will look the same. So how do we calculate the minimum number of degrees it will take? So this is always 360 degrees divided by the order. Again, and this is for non-regular shapes. So for example 1, which we said was order 3, we will do 360 divided by 3. So a rotation, the minimum angle of rotational symmetry will be 120 degrees. For the S, we said that was order 2, so 360 divided by 2, so a rotation of 180 degrees will map that figure back onto itself. For the recycling symbol, again, we said that was order 3. Divide that by 3, so again, 120 degrees will map that figure back onto itself. And for example number 4, this had order 1, meaning that only a rotation of 360 degrees will map it onto itself, so again, no rotational symmetry here. 360 doesn't count, if that's the only one. And that is it for non-regular shapes. We could also find, so again, that's just the minimum. To find the other ones, we would do the multiples of these amounts until we hit 360. So 240 will also map the figure back onto itself. And then 360, this is why it's order 3. Here's 1, here's 2, here's 3. So we have 180 and 360. So again, this is why this is order 2. There are 2 amounts that will map this back onto itself. 120, 240, 360. So again, 3 that will map it back onto itself. That's why it's order 3. And for the last shape, only 360. That's why it's order 1. And again, that does not count as rotational symmetry.